Now we continue problems on sum and difference of two angles. Let us see some problems here, and I can show you only few here just to see that. Prove the following. Number 1, cos of pi by 2 plus x is equal to minus sin x. Second, sin of pi by 2 plus x is equal to cos x. And here I am taking only few I am taking here. Cos of 2 pi minus x is equal to cos x, and the fourth one is sin of 2 pi minus x is equal to minus sin x. Even you have to consider that what I can say, sin of 5 minus x is equal to sin x, and cos of 5 minus x is equal to minus cos x. And you have to go for plus also, and one can see that 7 sin of minus 5 by c is equal to sin x. Sin of 5 minus 6 already is there, so pi plus x, you see, sin of 5 plus x is minus sin x. And we have to see that pi minus x, pi plus x. That you can see that 7 cos of pi plus x. Cos of pi plus x is, you have to go for minus cos x. And here you have understood that 2 pi by x and minus x. Even so many problems are there here, but I have to prove only few, and that too for the reference. Sin pi by x, cos pi plus x. And one thing, it is true that how these can be proved. Look this. Simple way I have to take number 1. But you have to remember, at last I tell you how to remember. These are not the problems, these are the results we get it by derivation. So cos pi by 2, look this, cos pi by 2 plus x. What is the formula? Cos of x plus y, x plus y. The formula is cos x cos y. Cos pi by 2 cos x minus sin pi by 2 sin x. This is the formula. So cos 90 is 0, that is cos x, and this is 1 into sin x. And you have to see this is minus sin x. Try to understand how you have got minus sin x. Similarly, you can go for third one I am taking here for just reference, 2 pi minus x. Minus is there, and here you have to see this cos 2 pi cos x. Here minus is there, here, then you have to write plus, what you say, sin 2 pi sin x. So cos 2 pi, you have to understand cos 2 pi is how much? Cos 2 pi is 0 into cos x plus sin 2 pi. Sin 2 pi is 1, and you have to see this sin 2 pi is 1 into sin x, and 2 pi minus x, this is equal to, you will get it See, once again you have to understand that how you get it 2 pi minus x, and that you have to get it. Cos 2 pi is how much, and sin 2 pi is how much. So that can be understood. Look this. This is 2 pi is here, and this point is a, that value is 1 0, and cos 2 pi is 1, this is 1, and sin 2 pi is 0, this is 0. So you have to get it. This is answer is cos x. So this is the way how to remember the results. So anyone you take like that, we can prove it. Just first, second I have taken. Now I take it this last one, you see. Just for reference I am taking this. Cos of 5 plus x. Cos of 5 plus x. So here you understand what we will get it. Cos x, cos y, plus here plus either minus, sin phi, sin x. So cos pi is here, and the coordinate is here a, b, c. Coordinate is you have to see minus 1 0. So now here you have to see that cos phi is 0 into cos x minus sin phi, and sin pi is here. Cos phi is how much here? So first one is cos pi is minus 1, you see, minus 1, and sin phi is 0, that is 0 into sin x. So what will be the answer? Minus cos x is the cos plus pi x, and you have to see this minus cos x is the answer, where it is cos of 5 plus x, and accordingly you have to go for finding the results. So however, you see all these results can be obtained by using x plus y, x minus y, and you have to substitute the result pi by 2, 2 pi according to that rules. That is more than enough. So these are the ways you can find out the results easily. So I am using the formulae, and we have got the results, and see that any result you can find out like this, and accordingly you can find out the results. Any result you can find out. Just I have shown you the reference, but later on I tell you the method how to remember. But why I am not doing means, in the examination they are not asking you to prove, but you must know the formula, and for that I tell you the formula how to remember. That is equally important. These results can be explained easily, and accordingly we have to go for it. Right now I have to do that tan of x plus y, tan of x minus y, cot of x plus y, cot of x minus y. That part also I am discussing. See here. Now I have to go for theorem 1 I take here. I have to prove that tan of x plus y. So when tan of x plus y you are discussing, see, prove that tan of x plus y is equal to tan x plus tan y 1 minus tan x tan y. So here you are understanding that how this can be proved, and accordingly you have to see the result. But one thing you have to understand, tan means sin by cos. Sin by cos, what you say? Tan, but this should not be 0. When cos is not equal to 0, when it is not an odd multiple of pi by 2. So what I say, x plus y, x and y are not odd multiple of pi by 2. None of the values x plus y, x and y are odd multiple of 2. None means not odd multiple. Then you can prove. Suppose they are odd multiple, you will not prove the result. So that is why I am telling that why you have to consider x, y and x plus y not odd multiple of pi by 2. If odd multiple of pi by 2, then what happens? Denominator is 0, because tan means sin by cos. Cos is 0. When denominator is 0, not defined. That is why none of x, y and x plus y are odd multiple of pi by 2. And here you have to understand that any one is not odd multiple of pi by 2. Then we have to prove this. So now I am proving that how this formula is obtained. Once you prove this formula, accordingly the trigonometrical identities, and using this you can go for proving tan of x minus y. So now I have to take it very easily that what is tan of x plus y. Looks very simple way I am taking. Tan of x plus y is equal to sin of x plus y divided by cos of x plus y. And you know that sin of x plus y formula, sin x cos y plus cos x sin y. This is a formula that already approved, divided by cos of x plus y is cos x cos y and minus sin x sin y. And try to understand that denominator is 1. So nr and dr divided by cos x cos y. What I say now, this is the numerator and this is the denominator. This is divided by cos x cos y. This is also divided by cos x cos y. When you go for cos x cos y, cos y cos y is cancelled. Sin x by cos x we get, it comes tan x plus cos x cos x is cancelled. Sin y divided by cos y, that comes tan y divided by, dividing by cos x cos y means it is 1, and sin x by sin x by, so both are, we can write that tan x and tan y. When nr numerator and denominator divided by cos x cos y, so this is the result. Tan x tan y, tan x plus tan y whole divided by 1 minus tan x tan y. So very simple, you can understand how it is divided. And here you note that dividing nr and dr by cos x cos y. And now we have to prove this x minus y. How we are this? The formula is tan x minus tan y, it becomes plus. And now I have to tell you how to prove this result. What I have to prove? Tan of x minus y is equal to tan x minus tan y. And you have to see this result, how we prove this tan x minus tan y divided by 1 plus tan x tan y. So basically, when you understand that result here, and accordingly we can proceed. And already that we have what? Tan of x plus y already approved. What? Tan x tan y, that already approved, you know, tan x tan y divided by 1 minus tan x tan y. This is a formula. So what I tell here, replace y by minus y. Then what comes here, you see, tan of x plus of minus y is equal to tan of x plus tan of minus y divided by 1 minus tan of x tan of minus y. So this comes tan of x minus y is equal to tan x, tan of minus y is equal to minus tan y. And here tan of 1 minus minus, here plus, here we write tan x tan y. And that too you have understood how you have got this result, and accordingly you can find. So now the important point is to be considered that how you can prove this result in the examination, not the question, but here we have understood how you have got this tan of x minus y is equal to. This is the way how to prove the results. Now I am going to see that next about cot of x plus y and cot of x minus y. That also we consider to prove the result. So theorem 2 I am considering. See carefully that how we prove, and prove that cot of x plus y, and like the previous one, you can go for that is cot x cot y. Look this, cot x cot y and plus 1 divided by, and here we are writing that how this can be proved, cot x cot y and cot y plus cot x, cot y plus cot x. So both are plus, now it is minus. Cot of x plus y is equal to cot x cot y minus 1, that too whole divided by cot x plus cot y plus cot x. So how this interesting is to be calculated, and accordingly we can see the result. But one thing it is true that here cot means you know cos by sine. When sine should not be 0 means what? That x or y or x plus y are not that multiple of n pi, multiple of n pi. If multiple of n pi, that you know sine 0, sine x is equal to 0, where x is equal to n pi. That is why if x is not equal to n pi, then only this is defined. That is why we tell that if none of x, y and x plus y is what? Multiple of n pi. What you say that is multiple of n pi, multiple of pi, you can say that. That is why you have to go for considering that n pi you are telling, you know, and accordingly we have to say that multiple of n pi. Suppose if it is multiple of n pi, that function is not defined, and we find sin x, sin y and even other results can be defined. If it is multiple of pi, and you cannot define it. Now let us prove that how this can be proved. Totally what I want to tell, why not multiple of that denominator should not be 0, that's all. So look here how to prove this that I am explaining. So accordingly the cot of x plus y is equal to cos of x plus y divided by cos of sine of x plus y. So what is cos of x plus y formula? Cos x cos y minus sin x sin y divided by sin x cos y plus cos x sin y. So the result is minus 1. Then what is to be done? You have to divide nr and dr by sine of sin y. If dr, nr numerator and denominator divided by, how to understand sin x sin y only? You see this minus 1. Dividing by sin x sin y means here you got it, that is cot x cot y minus 1. And when you write this dividing by sin x by sin x cancelling, cos y by sin y, you have to get it to cot y, and here you can understand again when you are dividing sin y, here it is nothing but cot x. So cot y plus cot x, this is the result. You can understand cot of x plus y. Now similarly one can go for writing that cot of x minus y, how that can be proved easily. So now you see that next problem, that cot of x minus y, and this is plus and this is minus. Let us see how it can be proved. Now you say that when this result is to be proved, first of all you have to understand the result. It's the same result I have to go for. We have the result. What is the result we have? See, cot of x plus y is equal to cot x cot y minus 1 divided by cot y plus cot x. So what I say, replace y by minus y. Then what? Cot of x plus of minus y. This is cot x. Cot of minus y minus 1 divided by cot of minus y plus cot x. So what you can understand here, that result, this gives cot of x minus y. See, cot of minus y is minus cot x cot y minus 1 divided by here minus cot y plus cot x. And here to find out the multiply nr divided by minus sign. So cot x cot y, and this becomes plus 1, and here numerator also multiplied by minus sign. This is cot y minus cot x. So this is the result for cot of x minus y. These are the ways how to prove the results, and accordingly we can go for it. I hope you understood that sum and difference of two angles. But now I have to go for understanding that how to explain the results in other case, that I mean to say trigonometrical ratios of allied angles I am discussing. What I say, trigonometric functions of allied angles. What do you mean by allied angles? Allied angles I have to discuss. First I tell you what is allied angles. In general we tell that allied angles means multiple of pi by 2. See, multiple of 90 degrees called allied angles. Suppose theoretically discussing, one angle is allied to another angle, and what is the condition? Their sum must be 0, or else you have to tell that their sum or difference definitely multiple of 90 degree or multiple of pi by 2. 90 degree means pi by 2. When you say one angle is allied with another angle, there are two conditions. One is their sum is 0. The other condition means sum or difference is multiple of 90 degree. Suppose if I say theta, what is allied to what? Minus theta. Why? Because when you are adding this, you will get it is 0. And similarly, if I go for one more example, that basically when you see that other in terms of allied angles I am going to discuss here, minus pi by 2 minus theta. So, and this is allied to what? And this is allied to what? Theta only. Allied to theta. Why? Because their sum is what? Pi by 2. Their sum is pi by 2. So what the specific condition you remember? One angle is allied to the another angle and their sum must be 0, or their sum or difference is multiple of 90 degree. Then they are called allied angles. But more in general, that allied angles are what you say, multiple of 90 degree. That is plus or minus pi by 2. So that is nothing but allied angles. Allied angles in general properties, we see that 0 is allied angle, and pi by 2, pi, 3 pi by 2, 2 pi, these are all allied angles. Why? Those angles are what you say, multiple of 90. For example, quadrant angles are allied angles, you say. Quadrant angles means, you know, 0, 90, 180, 270, 360, and there you have to see the multiple of 90 degree, so that they are called allied angles, that we can say. So the angles you have to tell in general, instead of this example, if I say that the angles, which angles are called allied angles, that multiple of 90, what I say, suppose if n into 90 plus or minus theta, whichever is integer, n is integer, you say z, or 2 into 90, 3 into 90 plus or minus, this is allied angle. Allied angle means it is of the form n into 90 plus or minus theta, you say. Suppose the question arises, which angles are called allied angles? You say simply what? The angles of the form n into 90 plus or minus theta, n into pi by 2 plus or minus theta are called allied angles. Finally, I tell you, allied angles means what? The angles of the form n into pi by 2 plus or minus theta are called allied angles, you can say. So now we have to discuss some important points that are regarding the allied angles that I am going to discuss. Suppose if I say that the results, how we have to remember, how to write, you will get nearly about 56 allied angle formulae that you can see. But here I tell you the methodology how to find out this, and I tell you the two rules you have to remember. For example, sine 90 plus theta, 90 minus theta, 180 plus theta, 180 minus theta, 270 theta, 270 minus theta, 360 plus theta, 360 minus theta. These are allied angles. Now we have to tell trigonometric functions of allied angles. For example, sine 90 minus theta, sine 90 plus theta. Like that you have to tell all, how many 6 into these allied angles, nearly about 56 formulae will. How to remember all these? Only two rules that I refer. One, suppose if it is 90 to 70, you know these are two allied angles, and 180, 360, and here 180 degree, 90 degree, 270. So these are also allied angles and these are also allied angles. Now here I tell that the rule says, if the angle is 90 to 70, trigonometrical function what changing to their cos ratio, sine to sine. That is called co-ratios we tell. Co-ratios. What is the co-ratio of sine? Cos. What is the co-ratio of cos? Sine. Like that, sine cos and tan cot. So both are here. And even you see that sec, what you say, cosec. So if 90 to 70 is there, trigonometric functions must be changed to their co-ratios. Co-ratio means what? Usually we tell in the human relation, co-brother, co-sister. It is not actual brother, not actual sister. And that is called cousin brother, cousin sister. That is why co-brother, co-sister we tell. So what is the co-ratio? Co-trigonometric function of sine is what? Cos. Cos, like that. If 90 to 70 are there, trigonometric functions must be changed to their co-ratios. Suppose 180 to 360 are there, you are not supposed to change. The trigonometric functions remain the same. Sine, sine, cos, cos, whatever the function is, they remain. Once again, 90 to 70 you change to their co-ratios, 180, 360 you need not change. They remain the same. And finally, second point is to say, second rule, the sign can be put plus or minus according to the ASTC rule. Means to say that according to the quadrant rules, all silver teacups I told in first quadrant which are positive, second quadrant which are positive, third quadrant which are positive, fourth quadrant which are positive. Already I have told you, first quadrant all are positive, and second quadrant sine and cosec positive, third quadrant cot and tan positive, fourth quadrant cos and sec are positive, and respectively the remaining all are negative. So the point is 90 to 70 you have to change to their co-ratios, and suppose 180 to 70 the functions remain same. And here you have to tell that how you can write all these functions. Just one tabular column I am doing because it is not possible to write it everything. But only I have to tell at least two functions or three functions that can be written here. So you have to go for that tabular column starting, and this is very important you to remember, otherwise you cannot do any problems here. And accordingly you have to see. The first is minus theta. Very important is to see that. sine, cos, tan only I have to discuss. First allied angle we have to take it minus theta, and next one is you have to go for that is 90 minus theta. See this, either you write in radian or degree, 90 minus theta, and 90 minus theta. Next what you have to tell now here, 90 plus theta. So I tell you all the table here, 90 plus theta. Next what, 180 minus theta, 180 plus theta. And next what, 270 minus theta, 270 plus theta. And you have to see this, finally you have to tell what, 360 minus theta and 360 minus plus theta. So these are the possibilities to write and remember how to go for writing the results. In only one table I can explain instead of taking this. And here you understand that in that column trigonometric functions, here what, trigonometric functions, and here that is allied angles. You can see what, allied angles. So anyhow, when you go for writing that trigonometric functions and allied angles, and you see these trigonometric functions are these, allied angles are these. Now you have to fill up this blank according to the rule I have told you. And see, one thing I can explain, that instead of 90, pi by 2, pi by 2, pi, 3 pi by 2, 3 pi by 2, 2 pi, 2 pi. So either we come across in terms of radians or in terms of degrees, whichever. So how to fill up this, and I am explaining you. Remember, no need of proving, but already I proved few, but here you have to remember that how this can be followed in this case. Now I have to explain that how to fill up this now. So accordingly you have to go for, the rule says the angles are particularly 90 to 70. See these, this and this, especially these two, 90, wherever 90, wherever 270, trigonometric function should be changed. And whereas when you go for writing that 180 and 360 not changed. So already I have proved sine of minus theta is minus sine theta, and cos of minus theta is simply cos theta. Tan of minus theta is, you see here, why I write minus tan theta? Because whenever you go for, this is fourth, if you go for fourth quadrant is always here, this you can go for theta, in terms of theta you are taking, this is minus theta. Minus theta you have to go for taking fourth quadrant. Fourth quadrant is tan is negative. Why fourth quadrant tan is negative? In fourth quadrant cos and sec positive. Now you have to see that 90 to 70, that trigonometric functions are changing. Sine becomes what? Cos theta. Here cos theta. See, and again changing what? Where changing? Here it becomes cos theta, cos theta. And here you see, when cos theta is there, changing what? Sin theta, sin theta. And here cos is there, you are writing sin theta, sin theta. And even in case of tan, this tan is nothing but cot theta and cot theta changing. Where is again changing here? This is cot theta and here also cot theta. So here I have to explain that about the sign. Simply we have changed, but sign we have to go for according to the quadrant rules I have told. Look this, 90 minus theta is sin 90 minus, how to read sin 90 minus theta is. So here you have to understand that 90 minus theta is first quadrant, this is positive, and sin 90 plus theta in second quadrant, sin is positive, this is also positive. That's right. 90 minus theta, sine is positive. But when you come to this again, 270 minus theta. 270 minus theta is nothing but third quadrant, it is negative. Third quadrant sine is negative. 270 minus theta is third quadrant is negative. And here 270 plus theta, fourth quadrant, this is also negative. And here you have to write the sign. And coming to this point, how to write the sign. And you see this cos 90 minus theta, first quadrant positive, and cos 90 minus theta, cos 90 second quadrant, cos is negative. Whereas you have to see that 270 minus theta. 270 minus theta is third quadrant cos is negative, and 270 plus theta it is positive because 270 plus theta is fourth quadrant. Similarly, tan theta 90 minus theta is positive, and 90 plus theta it is negative because sine is positive. So now coming to this 270 minus theta, third quadrant third quadrant tan is positive, right? And again 270 for fourth quadrant it is negative. So these are the ways how to write the positive signs. Now coming to the 180. So here no change, sine, and here sine, and here cos, and here is also cos, and here is also tan, and here is also tan. See, theta you can write. And similarly, you come to the 360. What? Here also sin theta, and here is also sin theta. And here also cos theta, here also cos theta. Here also tan theta, and here also tan theta. But now we have to put the sign for this. How to put the sign? Now, look this. Sine 180 minus theta. 180 minus second quadrant is positive. And look this. 180 plus theta. 180 plus theta. 180 plus theta is third quadrant. It is negative. And similarly, when you go for cos of 180 minus theta. 180 minus theta is second quadrant is negative. And 180 plus third quadrant is also negative. And when you see tan 180 minus theta is second quadrant is negative, and 180 plus theta third quadrant it is positive. 180 plus theta is positive. Now coming to the last, you see that sine of 360 minus the fourth quadrant sine is negative, and cos 3 positive, okay, and tan is negative. Now 360 plus theta first quadrant it is also positive, and this is also positive, and this is also positive. So these are the ways how to fill up this table and how to remember. That already I have told you. So this is the best way of remembering the allied angles. Now I am coming to the next part, that completing this allied angles, and we are going to discuss about the next part is nothing but multiple and submultiple angles. I hope you understood how these can be written and how we can put the sign of the trigonometric functions. Now, my plan is to discuss multiple angles. Multiple angles means what? Suppose x is an angle, 2x, 3x are called multiple angles. So 2x, 3x, and even don't say that 4x, 5x, that is also correct. But for our syllabus, only we have to discuss about 2x and 3x. There are the multiple angles. After the continuation to this, we go for submultiple. Submultiple means x by 2, x by 3 like that. But here we have to see only x by 2. And first of all, I want to discuss about multiple angles, trigonometric functions of multiple angles. Multiple angles. Example, you have to see this, that is 2x, 3x, etc. Now here, tan of sine of 2x and cos of 2x, tan of 3x you have to discuss. But instead, again, you don't try for that sec, cosec and cot, nothing else. So first we have to prove this result that 2x, and accordingly we have to see the results. Now, I prove the results in multiple angles, and in the theorem 1, see that how to prove this. What? Prove that number. First sine 2x, or you go for number 1, 2, 3. Because sine, cos, tan only you have to go for it, and accordingly we have to prove the result. First I want to go for the result is cos 2x. Cos 2x is cos square x minus sine square x, and here prove that. And cos 2x is, and you have to see that 2 cos square x minus 1, and 1 minus 2 sine square x. So this is first, and even you can tell in terms of tan, and accordingly we have to go for. These are the 3, totally 4 formulae you can prove the results here. So 1 minus tan square x, 1 minus tan square x plus 1 plus tan square x. This is the first one. First I want to prove this, and then I go for cos 2x, then I go for tan 2x. Let us understand how to prove these results. Look this, one by one, because I don't want to write all. If I write all, again getting confusion. How you prove all these results, and accordingly you can see the points here. Just I want to write how to prove this. Once you prove, and that you can remember, and you can continue the result here. And you know that we have, what is the formula? Cos of x plus y. Cos of x plus y formula is what? Cos x cos y minus sin x sin y. This is the formula. So here what I do, replace y by x. Then what happens? This implies cos of x plus x cos x minus sin x and sin x. Then what comes here? Cos 2x is equal to cos square x minus sin square x. So the first one is over. First one is over. Next, 2 cos square x minus 1. So what I do, this continuation, and if I write this is 1 cos square x, and sin square x formula is 1 minus cos square x. So this is cos square x minus 1 plus cos square x. So cos square x, how much? 2 cos square x minus 1. This is, see this second formula, you see, 2 cos square x minus 1. Now coming to, again, see this formula, cos 2x is equal to cos square x minus sin square x, where it is, and here I write cos square x is what? 1 minus sin square x minus sin square x. Then what do you say? 1 minus 2 sin square x. This is the third formula. 1 minus 2 sin square x. Now finally you have to go for how you get it, the result 1 minus tan square x. That also I prove here. See that how we prove this last one, and accordingly you can continue. So already we have seen, again, see this, again what? Cos 2x we have proved, cos square x minus sin square x, this we have proved. So this we can write cos square x minus sin square x and divided by cos square x plus sin square x I write. You are asking why you are written? Because cos square x plus sin square x is 1. Then no change. Then what I do it, divide nr and dr by cos square x. If you divide numerator divided by cos square x by cos square x is 1. Sin square by cos square means tan square x. And here 1 plus tan square x. And you have understood that this result you have got. This is the way how we have proved cos 2x. Now we have to go for like this, what you say, sine 2x you have to. This is cos 2x formula is over. 3 formulae, and you have to remember all 3, and whenever suitable the formulae that can be used. Now I have to write that second set of formulae related to sine, that is sine 2x is equal to 2 sin x cos x. So there we have got 4 formulae, where here you have to get only that 2 formulae, that is nothing but 2 tan in terms of that, and 1 plus tan square x. So sin 2x, 2 sin x cos x, and sin 2x in terms of tan, 2 tan x divided by 1 plus tan square x. And here you understand that how these two can be proved. Now I am proving this. After that we go for regarding 3x. First we complete this. Look this, sin 2x, and how that can be proved sin 2x. So basically the sum and difference of 2 angles that we have studied. So based on that we go for it. Look this. What? We have one formula that sine of x plus y. Sine of x plus y is sin x cos y plus cos x sin y. This is a formula that we have proved. And now here I write, replace y by x, then what we get? Sine of x plus x. So sin x cos x plus cos x sin x. Now what comes this? Sine of 2x is equal to sin x cos x, sin x cos 2 sin x cos x, that is there. So this is number 1 is correct. Now here you have to understand that how to prove the next one, and accordingly you have to see the result here. So when you write this result, how that third one is. Now we have, see that how we prove this. Sin 2x is equal to 2 sin x cos x. So this can be written as 2 sin x cos x divided by cos square x plus sin square x, and divide NR by what you say, cos square x. So what we get in the numerator? 2 tan x. So here that is tan square x. You have got it. This is the way how we prove that multiple 2x. Now I am going to discuss about tan 2x. I am proving now, and that is the way how we go for understanding the result. So let us, now I am going for tan. Sin is over, cos is over, and you try to prove that tan 2x is equal to, and you can understand 2 tan x divided by 1 minus tan square x. So here 2 tan x 1 plus tan square is there, but here we get it 1 minus tan square x, and there is only one formula that can be proved here. So 2 tan x divided by 1 minus tan square x. See how we get this formula, that I have to explain. But basically that you know the formula, tan of x plus y, and accordingly you can change the results here. But when you see that tan 2x formula, and accordingly we can write it. Yes, prove. What? Tan 2x. You have that tan of x plus y is equal to tan x plus tan y, the formula that we have proved, and 1 minus tan x tan y. So now here replace what? Y by x, then what? You see this? Tan of x plus x is equal to tan x is plus tan x divided by 1 minus tan x, and here also tan x. So this implies tan of 2x is equal to 2 tan x divided by 1 minus tan square x. This is the way how we have proved regarding this 2x. Similarly, we try for 3x. That is called submultiple angles. Later on we take. So now you have to go for taking sin 3x, cos 3x and tan 3x. If we prove these three identities, but one thing you remember, they may ask you to prove the same results in the examination. Number 3, 1, 2, 3. So I write prove that sin 3x is equal to what? And next number 4, prove that cos 3x is equal to how much? So here you understand that both are similarities are there. So 3 sin x, see here, 3 sin x minus 4 sin cube x. And at the same time, when you go for cos, and 4 cos cube x, 4 cos cube x minus 3 cos x. So these two are to be proved, and using the angles here. And similarly, you can go for the writing the results here. First, I want to prove this. What? See, solution. Sin 3x. Sin 3x means what? Sin of 2x plus x becomes 3. X and y. What is the formula? Sin of x plus y. Sin x, that sin is there. Sin x cos y means cos x plus, and cos 2x into, look here, sin of x plus y is sin x cos y, and again cos x sin y. So here you try to understand sin 2x formula is that only 2 sin x cos x and cos x, and here cos 2x formula there are 3, but here the answer only in terms of sin. That cos 2x in terms of sin is what? And that is 1 minus 2 sin square x. 1 minus 2 sin square x into sin x. Because you know that cos 2x is 1 minus 2 sin square, that already proved. So 2 sin x cos square x, and here you see sin x into 1 is sin x, and you have to minus 2 sin cube x. And here once again you write 2 sin x, again cos square is to be changed because no cos, and what is the cos square formula is 1 minus sin square x plus sin x and minus 2 sin cube x. So you have to multiply 2 sin x and minus 2 sin cube x and plus sin x minus 2 sin cube x. So here you understand 2 sin x and here 1 is sin x, it becomes 3 sin x, and minus 2 sin cube x minus 2 cube minus 4 sin cube x. So this result is correct, and that we have proved. Similarly, this last I want to prove this, how we have proved, because it carries 3 marks to prove the result. So here also we do same thing now. Cos of 3x is equal to cos of 2x plus x. And what is the formula? Cos of x plus y, cos x, cos x, cos y, and minus sin x, sin y. This is the formula. X is 2x and y is x. What is the formula here? Cos 2x. You have to substitute. But cos 2x 3 formula. But answer is cos. But cos 2x formula in terms of cos only you have to see this. And you have to go for that result when you are in terms of cos only you have to tell. And accordingly the 2 cos square x minus 1 here, 1 minus 2 sin square here, 2 cos square x minus 1 and cos x, and sin 2x is 2 sin x cos x into sin x. So multiply this 2 cos cube x minus cos x, and here minus 2 cos x, and sin x is sin square x. So once again you continue that 2 cos cube x minus cos x minus 2 cos x, and sin square can be written as 1 minus cos square x because answer is in cos. So last you see 2 cos cube x minus cos x and minus 2 cos x minus minus plus and 2 cos cube x. So 2 cos cube x, it becomes 4 cos cube x, and minus x minus 2x is minus 3 cos x, and that is the result we have proved. So this is the way how we prove the results, and like that I can continue in the next class, that is tan 3x, and that is the case where also we are using sum and difference of two angles. Thank you.